Maria Betswe and Karabo and Naileti, welcome back. Nice to see you again. And Marisa, hello. And what else have we got here? So you can get started on the do now, like we always do. Hi, Sinitlanla. Okay, hope you guys have got your notes and paper and pen and calculator, because we're going to need all of these in our lesson. And then just get started on the do now. And then we'll talk about those answers and then we'll get cracking. And Nolwazi, hello. Sihle, Nanwabo, David. Thank you, that's nice. Tatuka, cool Tatuka, so glad you're back with us. Thanks, Sihle. What a nice greeting. So I'm seeing a few new names tonight. Lonwabo, welcome, welcome. Okay, so like always, guys, we're just going to do the do now. Hopefully that's quite easy for you. And then we will move on to talking about finding the equation of the hyperbola. And then we're going to look at some exam questions tonight as well. So oh, Harrison, you're here as well. Cool. And Zayan, nice. And Nazol, Kelebochile. Afternoon, Luke. Elisa. Oh, wow. That's awesome to have so many people with us today. Okay, so I'm just going to wait one more minute. Thanks for the highs. That's awesome. I'm just going to wait one more minute for if there's anybody else that's still waiting to join us. Hopefully you have finished the do now or are very close to finishing. Not meant to be difficult. It's meant to be something that we're all supposed to be able to do by now. Just a little bit of practice with products. And we'll get started soon. We'll talk about our answers and then move on to what we've got planned. Okay. I hope I've given you enough time. I just obviously don't want to waste the precious time that we do have together. So I've got you to answer a couple of questions here. Does anybody, you're welcome to pop it in the chat, or you can unmute your mic and then speak to us. Does anybody have an answer for the first one, for H, that they're happy to share?
Would it be correct to say 11k plus 12?
For the first one, just say that again, please.
11k plus 12.
11k plus 12. Okay, now I don't think that's the answer that I would have got, But is there anybody else who got 11k plus 12? Anybody get another different answer? Even if it's not right, it doesn't matter, guys. We're all here together to learn. It's fine, even if we make mistakes. Do we know what this question is asking us to do? When we've got two brackets next to one another, do we know what it means? Foils, they aren't perfect. Absolutely, it means foil. Okay, so when we're multiplying a binomial with a binomial, that's exactly right. It's foil. So I'm just going to rub that out quickly. And foil, there we go. What did Harrison say? Harrison said 3k squared minus 2k minus 24. Okay, so Harrison, let's have a look at your suggestion here. Harrison said 3k squared plus 16k minus 12. Okay, cool. Let's work it out. Okay, so first, 3k times k is 3k squared, right? So that bit we've got. Then when we do the O part of FOIL, it's the first term in the first bracket with the last term in the second bracket. So 3k times 6 is 18k. Now later you've also put an answer in there. I'm going to have a look at your answer right now. 18k. You said 3k squared minus 2k plus 6. Okay, so you've all got a little something that's a little bit different. Okay, not a problem. And then we're going to multiply our nth terms together. So minus 2 times k is minus 2k. And then we've got to multiply last and last. So negative 2 times positive 6 will leave us with negative 12. Okay, thanks for all the suggestions. All right, so let's see who came up tops here. 3k squared. Now, if we start at 18 on the number line and we move 2 places to the left, quite right, we are going to end at positive 16. All right, and then minus 12. Thank you so much for all those suggestions. It just says Sabisi family. I don't know what your name is. Maybe you can just pop it in the chat, but well done. Your answer was correct. That was absolutely perfect. Okay, does that make sense to everybody? Are there any questions about that?
No, ma'am.
Sure.
Ma'am, can you please re-explain it? I don't understand it.
That's okay. I'll re-explain it. Okay. Do you understand the process of FOIL?
Yes, I do.
Okay. So you know that you're multiplying a binomial with a binomial.
Yes, ma'am.
Okay. All right. So let's just go through this one more time. Okay. We'll get rid of all of that. Okay. So the F part for FOIL stands for first. So when we are doing FOIL, it means that we are multiplying. Okay, so we are multiplying the first term in the first bracket. So in other words, 3k with the first term in the second bracket. So 3k times k will give us 3k squared. So 3 times 1 gives us 3, and k times k gives us k squared. Now the O part of FOIL is the outer terms. So 3k in the first bracket needs to be multiplied with 6 in the second bracket. So again, we're going to say 3k times positive 6 gives us positive. 3 times 6 is 18 times by the letter k. Then the I part of FOIL is the inners. So that's the 2 inner terms. So those 2 over there. Negative 2 times k. So negative times the positive is a negative. 2 times the invisible 1 is 2 times our k term. And then the L stands for last. So the last term in the first bracket with the last term in the second bracket. A negative times a positive is a negative. And 2 times 6 is 12. Okay, so each term has been multiplied with the other one, giving us 4 terms. The first term, 3k squared, is unlike any of the others. So it has to come down to the next line and be our answer. But these 2 terms over here that I'm just going to draw an oval around, Those are like terms. And in maths, if we can simplify anything, we're expected to be able to do that. So this means that we are sitting at 18 on the number line, excuse me, and we've moved 2 places to the left. Okay, so if 18 becomes too smaller, we're going to end at 16. Okay, so that's why this answer is plus 16. That's where we ended on the number line. And then we've got to have our k in it. And then minus 12 is also unlike anything else. So it also has to come down and be part of our answer. Anyway, I hope that was a little bit clearer. With this question over here, does anybody know what the square means? What am I supposed to do here?
We're supposed to write it out twice, ma'am.
You are quite right. Okay, Zion, you said double the sum. So 100%. So we're supposed to write it out twice because a square means we have to times something by itself. Okay, so this square here means times. So multiply the bracket by itself. Whoopsie. Okay, so now again, we're going to be doing FOIL. Let's use a different color. Okay, let's go with blue. Okay, so S times S is going to leave us with S squared. Okay, now we're going to do the O part. All right, so the outer term in the first bracket with the outer term in the second bracket. What should I write next? As a result of multiplying the outer terms, what should I write? You can pop it in the chat or turn on your mic. Well done. I should write
6s.
Well done. Exactly. So plus 6s. And what do I get from the i's?
Plus 6s again.
Plus 6s again. Quite right. Fantastic. Thank you so much. And what do I get from last and last? There we go. Beautiful.
36.
Plus
Plus
36.
Excellent. You guys are brilliant. Well done. Okay. And again, the first term S squared is unlike any of the others. So it has to be on its own in our answer. It can't be simplified with anything else. The 2 middle terms are like terms. If I'm sitting at 6 on the number line and I move 6 places to the right, where am I going to end up? What should I write next?
12s.
12s. Beautiful. And then plus my 36 at the end. Okay, unlike anything else. All right, so these ones have got 3 terms in their answers. 3 unlike terms, so they'll stay as they are. Okay, well, hopefully that was easy enough for everybody to understand. Let's move on now and get started with our lesson because our time is so precious to us. All right, so the first example that I've got, and I'm going to do this one with you, all right? So you guys can write this down in your books. And then the next one you're going to do on your own, all right? But before we get started, let's just go through what all these letters mean again, okay? So we've got a Y, okay, over here. I'm talking about this, okay? We've got Y, we've got X, badly written by me. We've got A, and we've got Q. All right, so we can't begin to answer a question like this until we know what all of these things mean, okay? So coming from last week, I'm going to call on somebody, and even if you don't get it right, it doesn't matter. So Nolwazi, I'm going to ask you, do you remember what the Q represents?
No, ma'am, I do not remember what the Q represents.
That's fine, no worries. Okay, so you're going to have to learn these, all right? Otherwise, it's going to be really... Yes?
Sorry, ma'am, to interrupt.
No problem.
I think the Q value is the shift asymptote, if I'm not mistaken.
That's quite right. Absolutely. Who's speaking?
Marisa.
Marisa, well done, Marisa. Sorry, I just missed that because I was looking at the chat. Marisa, you are 100% correct. Okay, brilliant. Well done for remembering that. Q represents the asymptote. Okay, weird word, isn't it? Asymptote. And that, if you remember grade 10s, is this dashed line over here. Okay, and this line is very special because it's a line that the function can't go through. All right, so can you see how the function comes all the way down from positive infinity here and it gets closer and closer to this line, but it can never ever touch it. That's why it starts to curve off onto the left-hand side like this. So this line, it can never ever touch, right? So that dashed line, that is the asymptote, that is going to be the value of Q. So in this case, if we have a look at the diagram, what's the value of Q?
2.
2, quite right. So if you know the value of the asymptote grade 10s, always sub that in first. So in other words, here we would have written y equals a over x plus 2. Now, before we can carry on, we need to know what a and x and y represent. Otherwise, we don't know what to do with the information that's been given to us. Who can remember what a was? What did a tell us about our graph? Can anyone remember from last time? Difference? What do you mean when you say difference, Marisa? Amplitude? Unfortunately, not amplitude, but amplitude is an important word, but that's if we're talking about trig functions. Does anybody remember the effect that A had on the graph? Ah, there we go. In Tafatsa, which quadrant our functions are in? Quite right. Sihle, yes. So either A could be positive or A could be negative. 100%. That's exactly what I was looking for. Well done. That's brilliant. So now, when you look at the picture, all right, what do you think? Which quadrant do you think it should be in? If we look at the picture, it's been sketched, well, sorry, what I mean is, what is the sign of A? It's been sketched in quadrants 2 and 4. Do you remember that from last time? Do you remember that this was quadrant number 1, and this was quadrant number 2, and this was quadrant number 3, and this was quadrant number 4? Okay, so it's been sketched in quadrants 2 and 4. So is A supposed to be positive or is A supposed to be negative? You can pop it into the chat. Positive, negative, what do you guys remember?
Miss, I think it's positive.
Well done, quite right. Yes, Sihle, yes, Harrison. Perfect. Okay, it's positive. Okay, unfortunately not, guys. It's not supposed to be positive. All right, when we sketched in quadrants 1 and 3, that was when it was supposed to be positive. Okay, so in 1 and 3, that's where A was positive, and when we were working in quadrants 2 and 4, that's where A was negative. So here, A is supposed to be smaller than 0. We want A to be a negative number. Do you remember why? Do you remember where the value of A comes from? It comes from multiplying which two numbers together? Can you remember? X and Y, yes, Rebetswe, that's quite right. So multiplying X and Y together. So now, if you look in quadrant 2, all your X's, so these numbers over here that I'm just putting little dots underneath it, those are all negative numbers, aren't they? All right. And then if we look at these numbers over here, that 1, that 2, that 3, that 4, those are positive numbers. Okay, so the only way that we can have a graph sketched in quadrant number 2 is if we're multiplying a negative number with a positive one. All right, so quadrant 2 and 4, if that's where it's sketched, A has to be negative. So we are expecting a negative answer. Whatever it is, we know that A has got to be negative. If it came out positive, we'd know we'd done something wrong. Okay, now the $1 million question. What are X and Y? Are they given to us? Is this something that we can use? Is it part of the question?
Ma'am, I think they're given to us.
They are given to us. And do you want to tell me what you think X and Y are in this case?
I think it's the numbers on the graph. Like the X has to be the numbers on the vertical line and Y is the numbers on the horizontal line.
Okay, well done. It's the other way around. The X-axis is the horizontal one. No stress. The X-axis is the horizontal one and the Y-axis is the vertical one. So now, Daniel, you're saying to us they are given to us. What numbers are we looking for, Daniel? What numbers do I want to use here? You're quite right. They are given to us. What numbers are they, Daniel? You can type your answer. You don't have to unmute your mic if you don't want to. So Daniel says these numbers are given to us, all right? And he's quite right. If we look up at the top, -2 and 3. Okay, I also see -2, Nazol. Here's a -2 over here, but then 5/2 is not going to leave us with 3. That's 2.5. Okay, or 5/2 if it's written as an improper fraction. Okay, so when we have a pair of coordinates, what value always comes first? Is it the X or the Y?
The X, ma'am.
Always the X first and Y second. Now, they gave us, thank you so much, that's perfect. Now, they gave this to us on purpose, right? Because they want us to use this to work out the value of the A. So I am going to substitute now, given this information, all right? I am going to replace Y with 5/2, the Y coordinate. I am going to replace X with what X was, which was -2. And then I've got to remember to write my +2 at the end. Okay, is everybody happy with that? So I've looked at the graph. I've seen that my asymptote is at 2, and I filled in what Q was. All right, so in a different color, there we go. That was me filling in the value of Q. All right, okay, Marisa, I'm glad. In my next step over here, the one that I put the little purple star next to, I am substituting this point up here that I'm underlining in purple. X is -2, Y is 5/2. So that's why I put in place of Y, I put 5/2. And in place of X, I've written -2. Now I have to solve for A. So now I want to know from you, what do you think I should do next? What would be our next step in this situation? Let's just move this up a little bit. So you can pop it in the chat or unmute your mic and tell me, what do you think we should do now?
We should start solving for A.
We should, absolutely. And what would be the first thing that you would do? If this was a question that you were expected to do by yourself, what would be the first thing you did?
I'll take the 2 to the other side, so that becomes 5/2 -2.
Brilliant. Brilliant. Sorry, I'm interrupting you. So I'm just going to write down what you've said, because that's perfect. So you're going to say 5/2 -2. Keep going. You were doing so well.
Equals to A over -2.
Beautiful. Okay, 100%. So we took the 2 over to the other side. Is everybody okay with that? So this +2 went over to this side and it changed its sign. That's why it became a minus. Okay, so now we can work this out. If we want to, we can do it on our calculators. What is 5/2 -2?
A half.
This is a half.
A half,
Oh,
ma'am.
a half, quite right. Okay, so I'm going to write that as 1/2. Perfect, absolutely. Yes, Marisa, quite right. 1/2 equals A over -2. Now, what are we going to do? We spoke about this a little bit last week. This is a very important move that we have to be able to make in maths. If we've got a fraction on one side and a fraction on the other side, what are we allowed to do here? Can anyone? There we go. That's it. That's it. You guys are perfect. Perfect, perfect. So cross multiply. So we are saying -2 times 1 is -2. 2 times A is 2A. Okay, so that way when I cross multiply, I get rid of the denominator on both sides. Now what do I need to do? I want to work out what A is. What should I do to both sides of my equation now?
Divide by negative
Divide by 2, ma'am. Divide by -2.
By positive
Okay.
2.
By +2, quite right. Okay, so I should rather divide by +2. Remember, we always want to divide by the number that's in front of our letter. Okay, so we're going to divide by +2 because we don't want negative A, we want positive A. So we're going to divide by +2. 2 divided by 2 leaves us with 1A, which I'm writing on the left now, and -2 divided by 2 leaves us with negative
1.
Perfect.
-1.
Indeed. Now, didn't we say in the beginning that we thought the answer should be negative? We did, didn't we? We did. We thought in the beginning when we looked at the graph, we looked at which quadrants it was drawn in, we had decided then that A would be negative. So that means that when we are working, we have to understand what it is that we're working with. We have to have an expectation of what our answers should be. So if we see a hyperbola and it's sketched in quadrants 2 and 4, like this one was, we're looking at it and we're saying to ourselves, well, A, whatever A is, it has to be a negative number. All right, if it's sketched in quadrants 1 and 3, then A has to be a positive number. Do you feel confident to try one on your own? Yes.
Yes, ma'am.
No. Yes. Okay. I like that. All right. Perfect. So
Yes,
I'm
ma'am.
going to move this. Good stuff. Well, well done. All right. So now it's your turn. Okay. So I'm going to be quiet for a couple of minutes and I'm going to let you guys have a look at this. And you are going to work out the values of A and Q, just like I've done. Okay. All right, so I'm not going to talk for a little bit, unless, of course, you're stuck with something. There's something that you don't understand, then please obviously unmute your mic, but try this by yourselves. Again, our live streaming audience, if you want to participate, you're very welcome. Please follow along with what I've said. You're also welcome to try and work out the values of A and Q. We're going to go through this shortly once everybody's had an opportunity to give it a try. Wow, you're done already, Harrison. That's fantastic. Good job, Harrison. Well done. I'm going to see. Erickson, I've got other questions here. They're a little bit further down. Okay, Norwazi, you also done. Okay, brilliant. Good stuff. Don't stress everybody else. Everybody finishes in their own time. Kelebohile, you said you done too. Awesome. So I purposefully did the more difficult one with you, and then I tried to make this one just a little bit easier. Okay, so I'm going to wait one more minute. And then we can talk about what the answers should be. And you're done. Cool. Well done. Well done, Nandi. Okay, Nazal, you say you're done as well. Sayan, done. Okay, that's great. Well done. I'm glad that you guys were able to done 2 rear bed square. Brilliant. Okay, fabulous. Well, then let's get started on marking this so that we can get onto the more difficult, well, not more difficult questions, but onto the other questions that we want to get done today as well. Okay, Marizo done as well. Fantastic. Okay, so I'm going to whip through this really quickly, and I hope that we've got the same answers. Okay, so who wrote down that Q was equal to 3?
Me, ma'am.
Good. Okay, so remember Q represents good rear bed square. I'm so pleased. Okay. Lovely. What does Q represent again, grade 10s? You can pop it into the chat. Q is the
Asymptote.
asymptote. That's it, the asymptote. Quite right. Perfect. Okay, so Q is the asymptote. So now our equation looks like this. Y equals A over X plus 3. Okay, and then what we were supposed to do is we were supposed to look at the information that was given to us, this point over here, and recognize that that is an X and a Y. So hopefully we all wrote 5 in place of Y. A is what we are solving for. X in this case is -1 plus 3. Okay, so now we have subbed in. All right, so now I would like one of you, Harrison, you were finished early, so you tell me what should I do now? Because I want to work out the value of A, right? So what's my next step, Harrison? What should I do?
You're going to take the 3 to the other side, which is going to give 5 minus 3 equals to A over -1.
Fabulous. Well done. Very nice, Harrison. Thank you. Zayon, do you want to take over? What should we do now? You can type it in the chat if you want to, Zayon. What would we have on the left-hand side of our equation? Maybe Zayon's feeling shy. Must be cross multiply. Yes, quite right. Quite right, Zayon. No, you're not feeling shy. Good, I'm so glad. I'm so glad you're talking. Okay, so 5 minus 3 leaves us with 2 Okay, so Zayan, cross multiply for me and tell me what I should write. Two over A. Are you right? I'm struggling to understand. 2 over A, or Zayan, if we're cross multiplying, then we're going to multiply -1 with 2, and we're going to multiply 1 with A. Okay, so I think that's what you meant when you were writing here in the chat. Okay, so A times 1 is positive 1A, and -1 times 2, it's fine, Zayan, no stress, is -2. Did anybody else get that answer?
Ma'am?
Yes, my
Ma'am.
love. Good.
Ma'am, I got that answer, but I did it a bit differently.
Okay,
When
what did you do?
when we're at 2 equals A over -1, instead of, cross multiplying, I took the -1 and times it with 2.
Perfect.
Since it's, divisible, then you...
Absolutely,
Yeah,
absolutely. So you just said I'm multiplying both sides by -1, 100% perfect. Same thing.
Okay.
Excellent. Well done. Good. All right. So a lot of people are saying, yes, yes, you got that answer. Fantastic. Well done. So now you've learned how to find the equation of a hyperbola. So let's move on and have a look, unless there are any questions. Let's move on and have a look at an exam type question. I've actually got 2 here. This is the first one. Let me just make this a little bit bigger. Okay. So we've got a sketch of a hyperbola, and they've told us we've got f of x equals k over x plus w, and g of x equals minus x minus 1. The graph G is an axis of symmetry of f. The graphs of f and g intersect at P and Q. Okay. Do we understand functional notation? So in other words, do we understand what f of x and g of x mean? Is that something that we're okay with? Grade 10s? So Daniel says yes. Cool, Daniel. Are the rest of you sort of? Okay. All right, so Nolwazi, just to give you a starting point here, you don't have to be afraid where they write f of x and g of x. All it means is, do you know, Nazol? What does f of x mean? What does g of x mean? Perfect, Daniel, 100%. All it means is y. It's just a different way of writing y. Okay, so the minute you see that, you don't have to be intimidated by it or confused by it. F of x is just another way of writing y. Correct, Sihle. F of x is y and g of x is y. Quite right, 100%. Okay, so because they've been sketched on the same axes, it's just easier for us to give them names, all right? So the hyperbola is being called f and the straight line is being called g, just so that we can differentiate between them, okay? Now, in this particular case, they haven't used the letters A and Q, right? So what letter have they used instead of A in the hyperbola? What letter represents A in the hyperbola, in the one that they've given? Indeed, Harrison, good. Okay, A is now being written as K. Does that matter? Is it important that they've done that? Does it change what it means? See here where you've said G of X is X. G of X means the same thing as F of X. It means Y output. All right, so Daniel, you've said no, man, 100%. No, it doesn't matter. Absolutely. And instead of writing Q, they didn't use the letter Q either. What letter have they used instead? the letter?
Oh, yeah, not that.
Quite right, Harrison. They've used the letter W. Are you okay with that, grade 10s? Right, so it means exactly the same thing. They've just changed the letters. Instead of writing an A, they've written a K, and instead of writing a Q, they've written a W, right? G of X is a straight line. So that's this function over here, the straight line, and they've told us that it is an axis of symmetry of F. Is that something that you have heard your teachers talk about at school when they've spoken about the hyperbola, an axis of symmetry? Do you know what those words mean? Has anybody heard the word axis of symmetry at school before? No, ma'am. Please, can you explain? No problem.
No, ma'am.
No problem. Okay.
No, ma'am.
100%. Okay, so when they talk about an axis of symmetry, okay, an axis of symmetry is a line that cuts another line in half, all right, or into two pieces that look like mirror images of one another. So if we think about, I'm just going to move this over a little bit, okay, and just create a little bit more space. Actually, let's do this. Let's go over here, okay. I hope you remember our sort of first lesson where we spoke about the parabola. And I'm drawing a set of axes here, not very well, should use straight lines, but anyway, it doesn't matter. Our parabola is symmetrical, right? So in other words, when we look at it, this line, the y-axis, it cuts the parabola in half. Okay, so the parabola is symmetrical about the vertical line. Let me just change the color here. Seki. Okay, so this side over here that I'm now, whoopsie, not doing very well here. It's a little bit hard for me to draw on my pad. This side over here that I've highlighted in red, okay, is the mirror image of the other side. Okay, so an axis of symmetry, in this case, the y-axis, it cuts this parabola into two equal pieces. So if you picked up the one and you put it down on the other one, they would look identical to one another. All right, so an axis of symmetry, you can write this down, grade 10s, an axis of symmetry means that we have created something that is a mirror image. Okay, so just like when we look in the mirror, all right, and we see a mirror image of ourselves, so this left-hand side over here is a mirror image of the right-hand side of the axis of symmetry. It's exactly the same idea with this straight line. Okay, so hyperbolas have two axes of symmetry. They have an axis of symmetry that cuts it in half, the way that it's being represented. But there's also an axis of symmetry that cuts it in half the other way. And we don't have to worry about both of them. But just like it can be cut, this is a mirror image. So now this line over here represents a mirror image. So if we were to mirror this arm over here, over this line, it would end up looking like that. There's also another mirror line that's going on in this diagram, and it cuts it into two equal pieces in the other direction. So the other mirror image is like that, okay? And then we have this on the one side, and we have that on the other side. That one's probably a little bit easier to see. I'm going to rub all of those out, okay? So as soon as we see the words axis of symmetry, we are thinking mirror image, okay? You don't have to be intimidated by those words. Okay, now the first thing that they want us to do, if we look at the question, is they want us to write down the value of W. Does anybody know what the value of W is going to be in this case? Well, if you don't know about the mirror image, about the axis of symmetry, you may not. Anyone got an idea of what the asymptote should be in this case? They haven't given us a dotted line. If the answer is no, don't stress about it. Anybody know? -1. Perfect. Perfect, Tandeka, that's 100%. Where did you get the -1 from? How did you know it was -1? Good. Fair enough. Okay, so because they've told us that g of x is the axis of symmetry of f, this line over here, g of x, is a line with a negative gradient. That's why it's -x. And then this at the end over here tells us that this line has been shifted down 1 unit. Okay, so because the axis of symmetry has been shifted down, it means that the hyperbola has also been shifted down. So this is a connection that they want us to make between these two things. All right, so that's why it's so important for us to know what an axis of symmetry is. Otherwise, we wouldn't be able to answer this question. So indeed, this graph has been shifted down 1 unit. Okay, so the value of W is -1. 100%, we're going to get 1 mark for that. Now, I'm going to move this up a little bit. They want us to work out the value of K. All right, and that's for 2 marks. I would like you guys to try and see if you can work out what K is by yourself. It's exactly what we practiced in the previous question. Remember, we said that K is the same as A. All right, and they've given you a point, an X and a Y coordinate that lies on the line. So let's see, can you work out the value of K? Give it a try. We know what W is. We're going to try and work out what K should be. As soon as you think you know what the answer of K is, you can pop it in the chat or unmute your mic and share it with us. It's not a problem. Cool, Harrison. No problem. If you'd like to, we'll just give everybody a chance to finish. Harrison, if you want to, please go on and do question 6.2.3 if you think you know how, calculating the coordinates of P and Q, because that's also something that's important for us. So I don't know if you think you know how to do that, but you can certainly give that a try. Okay, so let's see how everybody else is doing. Okay, so Sihle, Daniel, Zayon, Sinehlanhla, Nolwazi, Marisa, Nazol. How's it going? Okay, I got it. No, I don't, ma'am. Okay, Harrison, that's fine. No worries. No stress. K equals -16. David, you're saying I don't know. I'm sorry. We're going to go through it now. Done, ma'am. Okay, Naileti. Awesome.
Ma'am, I got 2 answers, like 2 different answers.
Oh, really? Okay. All right. Well, we're going to go through it right now and we're going to see which one should be right because we should have only got 1 value for K. All right. Okay, meanwhile, can you explain how W is -1? Sure. Okay, so Nazol, this is the bit that's going to be, it's a little bit difficult for you to understand, okay? When we are working with a parabola, all parabolas have axes of symmetry, right? And however many units the axis of symmetry has been moved down or moved up is the same number of units that the hyperbola has been moved down or been moved up. Okay, so if you have got, for example, and I'm going to whip all the way over to the left again over here. Let's go past that. Sorry, everybody, I just want to explain this because this obviously is important, and you can see in exam questions this comes up because these come straight out of DBE past papers. So we've got to know what this is. All right, so let's pretend that my hyperbola has been shifted 3 units up. Okay, so the asymptote is the line y equals 3. And let's pretend I'm sketching it here in the first quadrant, and I'm sketching it there in the third quadrant, right? If I have an axis of symmetry, it has to go through this new point over here as well, because the origin is not there anymore. The origin has been shifted 3 units up. So the line that we are looking at has a negative gradient, right? And it's gone through that same point as well, right? But it's been shifted 3 units up just like the graph has. So your axis of symmetry is a very badly drawn straight line. The one with the negative gradient would look like that. The one with a positive gradient would look like this. All right, so your axis of symmetry shifts up and down with your graph. So if your graph shifts up 1 unit, your axis of symmetry will also have to have +1 on the end. If your hyperbola shifts down 3 units, then your axis of symmetry will also have to have -3 on the end. So that's how we know. That's why those 2 pieces of information are so important. They are connected to one another, because if we didn't know that, there's no ways that we would be able to answer this question. Okay, so the answer actually comes from the other function, and that's because they told us that it was a line with a negative gradient, it was the axis of symmetry, and that it had been shifted down 1 unit. Okay, let's have a look, because we're always running out of time. Let's have a look. I hope that makes a little bit more sense. Let's have a look at what we should have got as a value for K, all right? Because I think a lot of you said you were done by now. Okay, so someone said -16. Who was that clever person? I'm looking up here now. There we go, Zayan. You said -16. That's brilliant. Excellent. Well done. Anybody else say -16? Okay, Ria Betsy, you got 4
That's
for
what I
K.
got, ma'am.
Well done. That was great. Well done. Harrison, you also got that answer. Good job. Nazol, yes. All right, lovely. Can you see grade 10s? They've done exactly the same thing in this answer as what we were talking about. Naileti, I got -16. I'm so proud of you. Well done, grade 10s. That's excellent. Can you see, just like I was talking about, the first thing that they filled in was the value of W, -1. Then they subbed in the point that we were given. This -2 and 7, they put the 7 in place of the Y, they put the -2 in place of the 6. Then what they would have done is they would have taken the -1 over to the other side. So it would have been 7 + 1, which would have been 8. They haven't shown this step. And if 8 is equal to K over -2, then we can either cross multiply, or I can't remember who said this to me last time, but you're absolutely correct as well. We can multiply both sides by -2, and that's why K would be equal to -16. Okay, and again, we're expecting a negative answer for K in this particular case because our hyperbola has been sketched in quadrants 2 and 4. Okay, anyway, well done. That was great work. So now you can see you've got 3 marks out of 7 so far, which is perfect. All right, so now if we want to get 7 out of 7, Harrison, you said you didn't know how to do this, and this is a little bit more of a difficult question. Let's see if we can do this one together. All right, they want us to calculate grade 10. This is a very typical grade 10 question. All right, they want us to calculate the x coordinates of P and Q. All right, so what do we call P and Q? We call them points of. Does anybody know? They're called points of intersection. Okay, so this is also something that's important that you need to make a note of. For points of intersection, the graphs are equal to one another, okay? At P, they want us to work out what the x values are. At P, they have the same x value. At Q, they have the same x value. And that's what they want us to do. They want us to work out what those x's are at P and Q. So what we have to do here is we have to let, they've called it f of x and g of x, we have to let f of x and g of x be equal. Okay, so that is our method. Now, what does this mean, letting f of x equal g of x? If f of x equals g of x, it literally means taking the two equations and making them equal to one another. Okay, so the one equation f, that's the one that we worked out. Remember, it was equal to minus 16 over x minus 1. That was f of x. And g of x, they told us, was equal to negative x minus 1. Okay, so that's making f of x equal to g of x. All right, so now let's quickly go through this. I'm just going to move that one down because we didn't get a chance to do that today. Doesn't matter. All right, now we've got to be clever in how we rearrange this. My recommendation to you, grade 10s, is get rid of the fraction first. So this is something, and again, it's something that we learned last year in grade 9. We might be a little bit rusty, but what we are supposed to do is multiply every term in the equation by the lowest common denominator, so by x. So I want to multiply every term. There's 2 terms on the left and 2 terms on the right. And I want to multiply each of them by my lowest common denominator, which is x. I'm going to multiply this term by x, this term by x, that term by x, and that term by x. Right, so when I multiply the first term by x, the x at the top and the x at the bottom cancel out, and I will just end up with minus 16. Minus 1 times x will leave me with minus 1x. Minus x times x will leave me with minus x squared. And minus 1 times x will again leave me with minus 1x. Now what I'm supposed to do is collect all my terms on the same side and make it equal to 0. So I'm going to bring the minus x and the minus 16 over to the other side. Or what I could do, which would probably be better in this case, is let me rather move these 2 terms over to the right-hand side. So when I move the minus x squared over to the left, I get positive x squared. When I bring this minus x over to the right, it's plus x. So that means minus x plus x, it'll end up being 0. And then I'm going to bring down the minus 16. All right, so now it's in standard form. Now we have to be able to factorize. Do you remember we had a couple of lessons ago where we practiced factorizing difference of 2 squares? And this is one of those situations where we need to be able to factorize difference of 2 squares. Does anybody remember how x squared minus 16 factorizes? Does anybody remember what it factorizes into?
Bracket x plus 3 bracket
Plus 4?
Plus 4.
Yes.
Plus 4. Plus 4.
Oh yeah, plus 4. Yeah, 4.
Plus 4. Okay, and what should I have in the other bracket?
Minus 4.
Good, beautiful, well done. Okay, yes, Sihle, 100%. Okay, so difference of two squares. We've got to be able to factorize. Okay, factorizing is a skill. It's a tool that we use all the way through to matric. Okay, so what this means for us is either x plus 4 is 0 or x minus 4 is 0, and there are our two solutions for x. Either x is equal to negative 4 or x is equal to positive 4. And now, grade 10s, we need to go back and look at the picture, okay? Look at P. P is sitting in the second quadrant, where x is negative. Q is sitting in the fourth quadrant, where x is positive. So when they said calculate the x coordinates of P and Q, we just want to go back and go and answer the question, all right? Remember, P was in the second quadrant and Q was in the fourth quadrant. So what that means is that at P, x is equal to negative 4, and over here at Q, x was equal to positive 4. Okay, and unfortunately, we've once again run out of time. Just very quickly, are there any questions? No. Okay, Zayan. Hopefully everybody understood that and you knew what to do there and you were following me. Okay, perfect. All right, so I'm going to hand over to Tula now. I'm sorry I've gone over time again. We could sit here all night and I still wouldn't be finished. Well, even though I'm sure you'd be tired of it. Okay, carry on.
Yeah, no, it's really okay. Hi, everyone. I'm just going to screen share immediately. And unfortunately, well, fortunately for your eyes, I'm not going to share my video today because of some technical difficulties. So I'm just going to quickly get into it as soon as this thing allows. Okay, here we go. So as you know, we are on our lesson 5 now. We just finished lesson 5 and we're going to lesson 6. So we're starting exponential functions next week. Not next week, actually. Yeah, on Thursday. Yes, we're starting exponential functions on Thursday. So be on the lookout for that. I'll show you by the end of at the end of this presentation, as always, where you can go, I guess, to get yourself acquainted with exponential functions and to practice and try to do some exercises before you come, so you are as prepared as possible. And our superstars for this week.
Oh wow!
This is popping up, and I'm seeing Anam's face, but I'm not seeing her smiling. So oh, there we go.
That's brilliant. Well done, Anam.
I know not everyone is comfortable with having the video on it, but it will be cool to see all these people turn on their videos, so I see all your beautiful faces. But this is awesome, guys. Anam, Tebo, Ozoma, Sinintla, Sipesihle, and Kanya. Thank you so much. A lot of you guys are actually here, which is awesome. Just yeah, this is good because it tells us that in addition to these live lessons, you go to the app, you do some activities, and you're constantly busy and trying to improve your maths. You're constantly trying to do some lessons, which is awesome. And I would encourage all of you guys. You guys are so awesome and you participate so much in the live lessons. I'm talking about all of you guys now. You do that. And in addition to that, it would be cool to further just go to the app, do some activities just to reinforce your learning and to make sure you never forget any of the things that you learn here. So congrats to these guys. And I hope I continue to see your names here, but also hopefully I hope to see some new names. So you guys will figure it out. And yeah, lastly, yeah, of course, to go to functions and relationships. By now, you guys know the drill on the Watobi app. You go to pick a topic, functions and relationships, and then go to sketching exponential functions. And then so here, this is where you'll get the lessons and the activities just to prepare for next week's lesson. And also remember that by the end of our, let me just go back to the first. by the end of, I guess, all the lessons, by the 19th, you should have finished the quizzes. There are quizzes there that you can find. There's one on the, so when you go here, here on functions and relationships, under this thing, it's just not showing now in the screenshot, but you see, for example, with the hyperbola, there's one for there's a quiz, there's one, I think, for the parabola as well, if I'm not mistaken.
Yes, yes, there is.
There's one for exponential functions. So you can do the quiz and make sure you do them as you go along. And by the end of, I guess, the function, so that we don't go on to a new topic and you're still not sure exactly if you understand, you know. So thank you, everyone. You guys have been awesome. You guys have been great. And if Lee doesn't have anything to add, I think we can let you guys go. And yeah, enjoy the rest of your evening. See you on Thursday. Bye.
Perfect. Thank you. It's a pleasure, Ria Betsware. I'm so glad you enjoyed it.